What's up, guys? Today we're going to be talking about solving quadratic inequalities. And this is a subject that it's a little bit weird for some people, but it's very important. And that really is the inequality part of it that's so different. We're going to be dealing with inequalities with lots of different types of functions throughout this year and as you move forward after this year. And it's important to understand the similarities between all the different types of inequality problems. Before we get into that, I want to talk about what it means graphically when we're solving a quadratic equation. Okay, so let's kind of recap what you learned last year and what we've learned so far this year. Think about a quadratic. We know that the graph of a quadratic makes a parabola. It makes a shape like this, right? And it could be upside down, right? If the leading coefficient was negative, it might instead go down like this. But it's going to look one of those two ways, right? When we talk about solving an equation, maybe you remember this and maybe you don't, but when we're solving a quadratic equation, what you're solving are the x-intercepts, okay? If I say that ax squared plus bx plus c equals 0, and I want to solve for x, what I'm solving for are the places where it crosses the x-axis. And maybe it crosses twice like this. That's the most it could happen. We're solving these quadratics. Most of the time, we keep getting two solutions. Well, there are some other options. You could get one solution. And in that case, how could this thing only cross the x-axis one time? It would have to cross right here at the vertex. So that's a possibility. That would be one solution, okay? Or you might even have no solutions. You might have the x-axis down here, but that's what it looks like graphically. This is what two solutions look like. This is one solution, and this is zero solutions, no solution, okay? And what this actually is complex solutions. When you have I in your answer, when you're doing the quadratic formula and you get some kind of I answer, this is what that really is. And all of this is stuff that you did last year in your geometry class. Okay, so of course, all these same things apply if it's upside down. It can cross twice like this. It could cross exactly one time, or it could cross no times like this. All those same rules apply. So in those cases, we're looking for the x-intercepts. Whether we think about that or not, we don't always think about the graph when we're doing algebra, but when we're solving a quadratic equation, there's an equal sign there, and we want to know, where is this quadratic equal to 0? Well, remember, 0, we're talking about in the y direction. That is the x-axis. So I have to say, where is this thing equal to 0? It's equal to 0 at this x value and at this x value, which are my solutions, okay? So what does it mean then when we start talking about inequalities? Instead of saying, where is it equal to 0, maybe I say, where is this graph? Let me draw another one over here. And maybe it crosses in two places like this. And maybe I want to say, where is this? And I don't even know what the equation is. Ax squared plus bx plus c, just representing any quadratic. Where is that greater than or equal to 0? Greater than or equal to 0? Well, at these 2 points, it's equal to 0, okay? But where is it greater than 0? It's greater than 0 right here and right here, okay? Now, we always give our answers in terms of x. So if I were to solve this like an equation instead of an inequality, I would just give this value and this value. Like maybe this is -1 and maybe this is 2, right? So that's like x equals -1 and x equals 2. At those values is where it crosses the x-axis. That's where this graph is equal to 0. So then I could say, well, where is this graph greater than 0? Where does it go above the x-axis? And that's anywhere in this part or in this part of the graph. So in terms of x, what's going on over here on the right? This is where x is greater than or equal to 2, and this is where x is less than or equal to -1. Again, remember, x is only talking about left and right, okay? If I were to plot a number line with 0 right here in the middle, that 2 would be right here, and that -1 would be over here, okay? And if I were to shade the part of this x-axis, the part of this number line, really, where it's greater than 0, where the graph is greater than 0, remember, it intersects here. and I want all of this part and all of this part. Those are the parts on the number line where my graph is greater than 0. If I wanted the parts where it was less than 0, where is this graph less than 0? It's less than 0 in between those two places, okay? And I would have to say between -1 and 2. But instead, I'm going to say anywhere that x is greater than 2, meaning I go to the right, and anywhere that x is less than 1, less than -1. Remember that x is always talking about left and right, and we only refer to pieces of the graph in terms of x. We don't use y to identify pieces of the graph because it's not unique. For example, if I say, well, like I said here, where is the graph greater than 0? Where is y greater than 0? Well, that happens in two places. It happens anywhere over here, all the way out to the right forever, and over here to the left, all the way out to the left forever. But if I say, where is x equal to 2? That's right here. Okay, there's only one place in the graph where x is equal to 2. It's right here. Okay, so we use the x coordinates to refer to the solution set for an inequality. Solutions for an inequality, it's a set or an interval. Okay, it's not just one or two solutions, it's a set of solutions. So in this case, you would express your solutions as x is less than -1, or x is greater than or equal to 2. That's what's called inequality notation. There's another notation that some other teachers use that you probably have used in the past, and maybe you prefer it, and I'm fine with that. That would be to refer to this interval, you would use it with the number line. Think about it this way. It's going from -∞ to -1. So you write it this way. And you got to remember the right parentheses and brackets to use. And then this would go from 2 to infinity. Now, remember the difference in the round and the square brackets. The parentheses means it does not include the number. The square bracket means it does include the number. Okay, this does not include. This does include. All right. We never include infinity. That's just kind of a weird, kind of little rule, but we don't ever include infinity. Infinity should always get around parentheses. That's just one you got to remember. Now, why did I include the -1, and why did I include the 2? Because there was an equal sign here. So my question here is, where is this graph greater than or equal to 0? Okay. At 2, the graph is equal to 0. So 2 should be part of my solution. At 2, when x is 2, my graph is equal to 0, which is part of greater than or equal to. Okay. If I were to say just greater than, if I didn't have the equal sign there, that means I only want to know where's the graph greater than 0, not where it's equal to. So I would not include the 2. I would only want the part where x is greater than 2 or where x is less than -1. I would not want to include the -1 and the 2. And so in that case, I would have used round parentheses. If there was no equal sign here, then this would have been the round parentheses. Okay. Of course, you can avoid this issue altogether of having to remember which one's which by simply using this method I use, which is just to use the inequality notation. If it includes it, then we use an equal sign. If it doesn't include it, then we don't use an equal sign. And it might be easier for you to remember. All right, so let's look at a couple examples. And we'll just look at a simple problem here because I want to focus on the inequality part, not so much the solving part. We can go back and watch the other videos or look at the other practice assignments in terms of solving a quadratic. I want to focus on what do we do that's different when we get to an inequality. So we'll just look at an easy monic quadratic. And maybe we'll just say, where is this greater than 0? We'll change it up a little bit, okay? So to solve this, first of all, I'm going to treat it like it's an equation. Okay, in fact, sometimes you might even want to just rewrite it as an equation. So I might just say x squared plus 5x plus 6 equals 0. Go ahead and just rewrite it as an equation. And then we'll say, well, we can solve this one by factoring. It's a monic quadratic. So all I've got to do is say x plus 2 and x plus 3. And of course, it equals 0 at -2 and -3. Those would be the solutions for this equation. Well, then the question is, what's the solution for the inequality? And this is why I always say make a sketch. Okay, and I've seen people do this a lot of different ways. Some teachers will tell you that you need to plug in test points, and that's perfectly fine. You might plug in test points on a number line, plug in something to the right of those numbers and something to the left of those numbers, and then something in between those numbers, and see where is it greater than zero, where is it less than zero. That's perfectly fine. Me personally, I'd rather just do it sort of visually. So what I like to do is do a sketch. Okay, it's a quadratic. That means it makes a parabola. It's positive out front, so it's a quadratic that looks like this. Now this doesn't have to be super accurate. All you gotta do is just make a sketch. Either it goes like this or it goes down, right? In this case it goes up because it's positive. It has two solutions, which means there's a line that crosses it twice. Now maybe it's more accurate up here or down here. I don't care about that part. All I care about is it's a upward facing parabola with two solutions, so it crosses twice. This is -3 over here, and this is -2 over here. Make sure you get the order right. Negative, positive, okay? So if this is where my graph is equal to 0, where is my graph greater than 0? That's the part up here. Okay, so my solution is when x is less than -3 or when x is greater than -2. If x is less than -3 or if x is greater than -2, I will get something greater than 0 in my graph. Okay, using the other notation, we'd say negative infinity to -3. Using round parentheses on both sides this time. Notice I didn't use equal signs here because there's no equal sign here. -2 up to infinity. Either one of these answers is fine. This is how I usually do it. Either one's acceptable. Okay, we'll do one more. And again, the solving the quadratic part might be harder. I'm sticking to easy examples just because I want to focus on this last part. Okay, if you need practice on solving with the quadratic formula or solving by factoring, and it's a harder type of factoring, you can practice that all day long. But right now I want to focus on the inequality part. So they won't always be this easy in terms of the solving part, but we can look back at previous videos for that part. All right, so let's just do another easy monic quadratic. X squared, let's just say plus 6x plus 8. And I want to know, where is this less than or equal to 0? So again, we're going to factor this. It's monic. It's easy to factor. It's going to be x plus 2 and x plus 4. Okay, and I'll just say equals 0. We'll treat it like an equation. That means for the equation, x has to be equal to -2 or it has to be equal to -4. Okay, if I plug in -2 or -4, I will get 0, meaning it's a positive quadratic. It has two solutions. Those solutions are -4 and -2. Now I want to know this time, where is my graph less than 0? That means I'm looking at the part in the middle here. I want to know, it's when it's between -4 and -2. When x is in between -4 and -2, I will get something less than 0. Okay. So if I want to write this using my inequality notation, then I would say x has to be between -4 and -2. When you have a closed interval, meaning your x is in between two numbers, then you want to write it in one inequality like this, a compound inequality statement. You're saying it's got to be less than or equal to -2, but it's got to be greater than the -4. Some people have a really hard time understanding this, and I try to simplify it this way. There's only two answers you can get, essentially. Either you've got less than something and greater than something, or you've got that it's in between two things. Because no matter what happens, you only get three intervals. There's the part on the left, the part in the middle, and the part on the right. Okay? If it's the part in the middle, here's what you need to remember. These inequalities should always face the same direction. I'm going from low to the next highest to the next highest. X is bigger than the -4, but it's less than the -2. Okay? It's almost the same way you would write the solution if we were dealing with the interval notation. If you like that notation, that would actually just be -4, -2. And since there's equal sign here, then we're going to use the square brackets on this one. But notice the similarities between the two, okay? A lot of times people, they don't like these. They're okay with this, but they don't like this. And since they don't like this, they'd rather use this method. And if that's you, then that's fine. But I want to point out to those people that this is really the same thing as this. Do you see the similarity? we're saying that it goes from -4 to -2 and that x has to be in between those. And then you just make sure that this is facing the same way every time. It goes low to high, just like this does. This should go low to high. This should go low to high. So it's less than, because you're getting bigger as you go to the right.